Interest rates. Interest rate is simply the price that you have to pay for the money. It depends on the demand and supply of it. Let's look at the above regularities on the graph. If supply of money increases, with all other conditions being equal, then the interest rate decreases. And vice versa. If supply of money decreases, with all other conditions being equal, then the interest rate increases. Opposite is true for demand on money. If demand on money increases, with all other conditions being equal, interest rate increases. And vice versa. If demand on money decreases, with all other conditions being equal, then interest rate decreases. And now very short definitions of capitalization and compounding. Capitalization means calculating of interest, while compounding means calculating and reinvesting of interest. We have three most important interest rates. First, nominal rate, also called the quoted or state rate. This is an annual rate that ignores capitalization made more often than once each year and compounding effects. It is stated in the contracts together with period. For instance, 6% monthly interest. This means that 6% annual interest is charged in monthly intervals 12 times a year. Or 14 weekly interests. This means that 14% annual interest is charged in weekly intervals 52 times a year. Periodic rate. This is the amount of interest charged for each single period of a year, for instance monthly or quarterly, which ignores compounding effects. It is calculated by simply dividing nominal interest rate by the amount of capitalizations within a year. For instance, M equals 2 for semi-annual capitalization, M equals 4 for quarterly capitalization, M equals 6 for capitalization made each 2 months, M equals 12 for monthly capitalization. The last one, effective or equivalent annual rate, is the annual rate of interest actually being earned, accounting for capitalization made more often than once each year and compounding effects combined. It is calculated using the following formula. Effective annual rate equals 1 plus nominal interest rate divided by number of capitalization within 1 year raised to the power of number of capitalization within a year minus 1. It is very important to calculate effective annual interest rate correctly because it allows us to compare compound investments with different capitalization intervals. Let's look at the following examples in order to clarify things a bit. Example number 1. What is more profitable for you? Receiving 10.3275% annual interest or receiving 9.95% interest compounded quarterly? In order to compare these two investment possibilities, we need to find effective annual interest rates for them. In the first case, we have 10.3275% annual interest. This is nominal interest. Number of capitalizations per year M is 1, so our effective interest rate is 1 plus nominal interest rate divided by number of capitalization raised to the number of capitalization minus 1. So the result is 10.3275%. As you can see, if number of capitalizations per year is 1, then our nominal interest rate equals periodic interest rate and effective interest rate. In the second case, we have 9.95% annual interest compounded quarterly. This is also nominal interest. Number of capitalizations per year M is 4, as we have 4 quarters within each year. So our effective interest rate is 1 plus our nominal interest rate divided by 4 raised to the power of 4 minus 1 equals 10.3275%. Both possibilities have exactly the same profitability, so it is indifferent for us between receiving 10.3275% annual interest and receiving 9.95 interest compounded quarterly. We can also do both calculations using Excel's effect formula. Let's have a look. So in Excel file, we are looking for effect formula. Our nominal rate is 10.3275%, while number of capitalizations is 1. As we see, in this case, our effective interest rate equals nominal interest rate. In the second case, we are also using the same formula. However, in this time our nominal rate is 9.95%, while number of capitalizations equals 4. So our effective interest rate is 10.3275%, is exactly the same as in the first case. Example number 2. Calculate effective return for investment with the same nominal rate, 11.5%, but different compounding intervals, daily, weekly, monthly, quarterly and semi-annually. In order to solve this example, we must use our formula on effective annual interest rate, where M for daily capitalization is 365, weekly capitalization 52, monthly capitalization 12, quarterly 4, and semi-annually 2. So our effective annual interest rate for semi-annual capitalization equals 1 plus interest rate divided by 2 raised to the power of 2 minus 1 equals 11.83%. Our effective annual interest rate for quarterly capitalization equals 1 plus interest rate divided by 4 raised to the power of 4 minus 1 equals 12.01%. Our effective annual interest rate for monthly capitalization equals 1 plus interest rate divided by 12 raised to the power of 12 minus 1 equals 12.13%. Our effective annual interest rate for weekly capitalization equals 1 plus interest rate divided by 52 raised to the power of 52 minus 1 equals 12.17%. And finally, our effective annual interest rate for daily capitalization equals 1 plus interest rate divided by 365 raised to the power of 365 minus 1 equals 12.19%. We can also do all above calculations using Excel effect formula. In Excel file, we are looking for effect formula. Our nominal rate is 11.5% in all cases. However, in case of effective annual interest rate with semi-annual capitalization, number of compounding periods per year is 2. And effective annual interest rate for semi-annual capitalization equals 11.83%. In case of quarterly capitalization, nominal rate is 11.5%, while number of compounding periods per year is 4, as we have 4 quarters per year. Effective annual interest rate for quarterly capitalization equals 12.01%. In case of monthly capitalization, our nominal rate is 11.5%, while number of compounding periods per year is 12, as we have 12 months within a year. Our effective annual interest rate for monthly capitalization equals 12.13%. In case of weekly capitalization, nominal rate equals 11.5%, while number of compounding periods per year 52. In that case, effective annual interest rate for weekly capitalization equals 12.17%. And finally, for daily capitalization, our nominal rate equals 11.5%, while number of compounding periods per year is 365, as this is the number of days within a year. In that case, effective annual interest rate for daily capitalization equals 12.19%. As we can see from this example, our effective annual interest rate is the higher is the number of capitalizations within a single year. Example number 3. Calculate nominal, semi-annual and quarterly rates equivalent to 6.6% effective annual rate. In order to solve this example, we must use formula on effective interest rate, where m for semi-annual rate is 2 and quarterly 4 accordingly. Our effective interest rate is 6.6% and we are looking for nominal interest rate. In the case of semi-annual rate, we use the formula from our previous slide, where effective interest rate equals 6.6%, while m is 2. So, what we need to do is just to simply calculate the result. So we receive 6.49%, which is the number we are looking for, the nominal semi-annual rate. We are looking for nominal quarterly interest rate the same as we were looking previously, the semi-annual rate. So our effective rate is 6.6%. However, in this case, our m is 4. So, right now, we just simply need to calculate the nominal rate from our equation. So, our nominal quarterly interest rate is 6.44%. This is the number we were looking for. We can also make both calculations by using Excel's nominal formula. In this case, we are looking for nominal interest rate, and we can use nominal formula. In first case, we put as effective interest rate 6.6% and number of capitalization 2, and receive 6.49% of nominal interest rate with semi-annual capitalization. In second case, we have the same effective rate. However, number of capitalization is 4. So our nominal interest rate with quarterly capitalization is 6.44%. Example number 4. Calculate periodic bimonthly rate equivalent to 7.1% effective annual rate. In order to solve this example, we need to use our formula on effective interest rate, where number of capitalizations, m, is 24, as we have 2 capitalizations per month, and effective interest rate is 7.1%. We are looking for periodic interest rate, which equals nominal interest rate divided by number of capitalizations. So, let's calculate. We know from the example that our effective rate is 7.1% and M is 24. So what we have to do is just simply calculate. So our periodic interest rate equals 0.2862%. Example number 5. An entity sets up a 2-year deposit with a nominal interest rate of 9.7% payable at the end of the operation. What is the effective annual rate for the operation? In this case, we also are using our formula on effective interest rate. In this example, our M is 0.5 because we have only one capitalization within the whole 2-year period. A nominal interest rate is 9.7% and is payable at the end of the operation. So we have half capitalization per year, one capitalization divided by 2 years. We are looking for effective interest rate. So by doing simple calculation, we are finding our effective interest rate, which equals 9.27%. Thank you.